So this is just to give an overview again to the beginners or the fresh people who have no prior knowledge about Open RAN. So we'll start with the wireless telecommunication system. So this is also discussed by Sir Joel, and I will just try to supplement or add additional information on that topic. So in our wireless telecommunication system, we have three major parts. So you have the user terminals, okay? So these user terminals are considered as your smartphone, iPad, or Android phone, or tablets, anything that you use to connect to our cell sites or radio access network. So that is considered as the user terminals. So it also differ in terms of names if you are using it from different technology. For example, you are using it for 2G. The name is called the mobile station. And for 3G, 4G, and 5G, we call it the user equipment. But definitely, it's a typical cell phone or the mobile phone. Then we need to connect it to our radio access network, typically known as cell sites. And we call it the radio access network. And the radio access network and the user terminals are connected via air interface using a radio frequency or a spectrum. So it's just a matter of connecting the dots. So the user terminals are connected to the radio access network, and the radio access network will be connected to the core network, okay, via backbone system. The same thing goes with the radio access network. If our radio access network is functioning in a different technology like 2G, 3G, 4G, and 5G, they also have different names. For example, in 2G, we call it the base transceiver station or the BTS. For 3G, we call it the E-node B, the node B, and the 4G is called evolved node B. And for the 5G, in this example, we call it the G node B or the next generation node B. So the radio access network is connected to the core network via backhaul connection. This is what Sir Uro also mentioned, that one of the challenges is the connection, transmission bandwidth. So for the RAN, we can connect it into to the core network in three major ways, like a microwave, wirelessly, via fiber or copper cable, or via satellite. Okay, so these are the major three components of a wireless telecommunications system. So if you go for RAN, if we are talking about cell sites or radio access network, it comes in different structures or different forms. So you can see radio access network or cell sites almost everywhere. Kahit saan kayo pumunta, no? Lalo na dito sa Pilipinas, we are surrounded by different radio access networks or RAN. So we have what we call the four-legged towers or SSTs. So these are the type of structures ng RAN na kayang mag-support ng lot of loads, no? So, like marami antennas and like of microwaves and radios. And there are also types of RAN na naka-install sa roof deck. So we call it the rooftop sites. Meron naman tayo mga what we so-called the guide tower. Okay, so these are special type of tower na supported by guide wires. And typical, the tower loading of this is not as much as the four-legged towers. And we also have the cell site on wheels or the emergency cell sites. So we typically the operators are deploying this type of runs in special occasions or disaster areas. So to give mobile coverage, no, or add additional capacity. And then we also have the monopole towers and the camouflage solutions. So if there are some areas that require some aesthetic requirements, so we deploy this kind of camouflage solutions. And there are also wall-mounted solutions or wall-mounted sites, especially in urban areas where there are skyscrapers presence, no, in the area. And of course, for the private networks, there are cell sites or RAN that can be deployed as a private network as a typical example is like this, no? So there's a network in a box setup. So if you are deploying, if you are curious how the mobile or the radio access network gives mobile coverage, so just think of it as this example, no? So that you can appreciate, no, yung importance ng isang radio access network sa area. So for example, meron tayong typical area like this surrounded by people, and then we want to give them mobile coverage. So if you have a mobile coverage, mobile coverage is parang meron kang signal sa cellphone mo, no? Meron kang bars, number of bars in your cell phone. So for you to be able to see that, so there should be a presence of radio access network. It could be a traditional RAN that was mentioned in our discussion earlier, or an open RAN system. Either way, both solutions can give us mobile coverage. But the most important thing is to build a mobile station, or a base transceiver station, or an eNode B or a Node B in your area. So when we build a cell site there, so typically yung mga operators natin will build this cell site, which requires some cost, as mentioned by our previous speakers. And the cost is syempre it's very important part of the considerations, no, when we are trying to build a cell site in the area. And considering also yung needs ng ating mga subscribers. So remember, operators are always thinking about the experience of their subscribers. So they want, as an operator, they want to give the best experience to their subscribers. So they build this kind of infrastructures, no, to give mobile coverage. So once the cell site or the radio access network is built on that area, so medyo may ano lang to, no? Medyo may konting exaggeration yung height ng cell site natin. But if you try to do a simulation, you can see that operators can see, no, the extent ng coverage ng isang cell site. So they can do some simulations, and you can see that in the area previously na walang signal, once na nagbuhay sila ng cell site yan, you can see that there will be an improvement in mobile coverage. So you will see here a different color that illustrates different signal level. So like for example, in dark blue, you will have a full bar even though you're nasa loob ka ng bahay. And you have a full bar dito ng mga blue na to kapag ka nasa labas ka. And then when you're experiencing nasa cell edge ka, so you will experience 2 to 3 bars, and until mag-red na yan hanggang sa mawala. So you can see na limited lang, no, yung coverage ng isang radio access network or RAN. So due to its height and transmit power. Okay, so the same goes with the implementation ng Open RAN. So you can see here na kinakailangan natin mag-build ng isang tower or infrastructure to give mobile coverage. And one tower is not enough. Most of the time para may cover natin yung isang area, same as like our example for this slide, no? So mayroong mga areas dito na hindi na inaabot ng ating mga typical sites. So ang solution natin is to build another site or build more sites on these areas. Okay, so this is the illustration of how important mobile or radio access network to a certain area. So this is an outdoor solution. So what will happen if since we are limited, no, the power is limited, the height is limited for a radio access network to give us a sufficient mobile coverage. So operators really need to build a lot of sites within the Philippine area. Okay, so different parts of the Philippines. And we need to build sites to have seamless coverage. Okay, so we are building different or numerous cell sites in different parts of the Philippines to give seamless seamless coverage and mobility. So when we say mobility, so when you are driving, like for example, from NCR going to North Luzon, so you will be driving in North Luzon Expressway, hindi mapuputol yung tawag mo, no? So because there are cell sites built, no, designed to handle your call while you are on the move. So ito yung mga kailangan natin. And that's why operators are keep building sites, no, to give us this seamless experience to their subscribers. So this is more on the implementation of radio access network on the outdoor. So nakita natin kanina, there are buildings or there are establishments that cannot be reached by the outdoor sites. No? So what are we going to do with that one? So there are solutions that we call the in-building solutions. So in-building solutions, these are the RAN solutions na ginagawa natin inside the building. So to give them sufficient coverage, capacity, and quality. So for example, you have a typical building like this na hindi na inaabot ng signal ng outdoor. So operators are building another set of RAN inside the building. So the equipment that we use in the outdoor is typically usually the same we use in the IBS. Unless it is a small cell or a Pico solution or other solution. But if we are deploying in building and we are using the DAS or the distributed antenna system, we are using typically the same equipment. So they can use the typical traditional RAN or the Open RAN. So what they do, instead of using one antenna, they are using a distributed antenna system or the DAS. And then this distributed antenna system gives coverage inside the building so subscribers can enjoy the services offered by the operator. Okay. So if you look at it on the top top view, so this is a typical example, no? Ito yung ating side view nung implementation ng in-building solutions. So indoor coverage is also important to provide subscribers with good coverage, high quality, and sufficient capacity with optimal cost of implementation. Okay. So if you have the floor plan of the building, so this is a top view of the floor plan of the building. So what happens is that operators are putting different antennas or distributed antennas. Okay, so these are the antennas, no, na nilalagay nila dyan sa loob ng mga buildings na yan. And then when they fired up the radio access network equipment, so you will have a sufficient coverage and good quality in the area. So this is how they solve the problems inside the buildings, no? Inside the buildings. So it requires an in-building solution. So there's a different type of solutions that they are offering. So it could be a typical base station inside the building or a repeater solution. Okay, or even an optimization, no? Optimization of the outdoor sites. So using these solutions in the outdoor and the indoor, so what we're trying to say here is that you can also use these solutions in the traditional RAN for Open RAN. Okay, so it's almost the same configuration. It's almost the same implementation. So what we're looking at on the deployment scenarios of Open RAN, okay, aside from the examples mentioned earlier, is for example, this is the coverage extension and site densification. Okay, so if implemented well, so Open RAN technology will have, as mentioned earlier, will have a total lower cost of ownership or the TCO. So in comparison with the traditional RAN. Okay, because deploying RAN is entailing a lot of capex and opex, no, operational and operation expenses and capital expenditure. So from the recent example, if you're looking at the Rakuten deployment in Japan, so when they deploy the Open RAN 4G and 5G, so Rakuten is a typical example of a greenfield solution. So they reported comparative reduction of 40% in CapEx and 30% in OpEx using Open RAN. So that's the number one. So coverage extension and site densification. Next is new deployments in urban and suburban solutions. system replacements and upgrades, rural coverage. So for those areas that needs to extend coverage, especially in the rural areas. And of course, support of private and neutral host networks. So this one was mentioned earlier in the question. Like for example, yung mga tower sharing solutions, tower sharing companies can also use this solution. So instead of sharing the tower, they could also explore sharing the radio access network using the Open RAN. But this one needs proper communication and further study because this will affect yung deployment, cost, and some competencies needed. Okay, so those are the deployment scenarios that we can have for the Open RAN. So you can deploy Open RAN for outdoor, and you can also deploy Open RAN for indoor, as I shown you earlier. So there is a community that is specifically deploying or defining the guidelines for the indoor solution, which has the Open RAN in mind. So they call themselves as SCF, the small cell forum. So they are deploying or making guidelines and specifications of deploying Open RAN in the in-building for in-building solutions, or particularly small cells. Okay.